Okay, so a lot of this information in terms of how to connect and stuff are available on cac.engine.umich.edu, which is, if you look on the left-hand side of the screen, you'll see the getting started and login nodes and transfer nodes, which is generally going to be what you want to look for. The thing about using high-performance computing systems or any type of remote computing system is that generally, they're in a physical data center that you don't have access to, and you need to connect to it remotely. You can do that from pretty much any platform out there. And the way you do that is using something called SSH, also known as Secure Shell, which opens a secure connection between you and a login node or server that you're connecting to. So the first thing we're going to cover is actually how do you connect. And we're also going to cover the basics, some of the basic simple ways to transfer files back and forth, and that is called SFTP, or Secure File Transfer Protocol, which is very different than FTP. A regular FTP client generally won't work for transferring files to and from a system like this. You need an SFTP or an SCP client. SCP is Secure Copy. A few things specific to Flux is that our login nodes only allow you to connect from on campus. There's a couple of little tricks to doing that. Is you can first SSH to campus, like login.itd or login.engine.umich.edu, and then SSH from there into the Flux login node. Or you can use the ITS provided VPN client. If you go home and you install the ITS VPN client, you can use, if you start that, and I'm actually running through the VPN client right now, you'll be able to SSH directly to a Flux login node, use SFTP, SCP from your home machine or hotel machine, just as you would if you were sitting on campus. I'm also going to do a quick run through of the Globus transfer, which is kind of not standard, but it is very high performant, highly reliable, and great for moving large quantities of small files or moving very large files that take a long time to transfer. It's great because you don't have to set up any firewall rules or anything like that, and also we do allow Globus transfers from off campus. You will also need a M token to be able to log into Flux. Again, this is specific to Flux. An M token is a little keychain dongle. They used to have a picture of it on here. It's a little keychain dongle that has a changing set of numbers on it that's uniquely tied to you. What this does is, it's the reason it's called two-factor authentication, is you have two factors to prove who you are. Your password, something you know, and your token, something you have. This way, if someone guesses your password or compromises your account on another machine, and they capture your password and they try to connect to Flux, they can't actually log in because they don't have the physical token that has the changing number on it to prove that you also are in physical possession of that token. So this basically solves all the security problems we've had in the past of people's passwords being compromised, because that's a very common thing. I encourage you to use strong passwords for UMich. The passwords we use are the same ones you use to log in to check your email, Wolverine Access. So if you need to reset your password, we can't actually do it. You need to reset your password with ITS. Okay, so how do we actually connect to the system? We use SSH. And so here on the login node page, we actually do have links to a couple of different tools to use. But I'm just going to go ahead and show it to you. So I'm going to do the version that exists on Mac and Linux first. Okay. So on Mac or Linux, we have a piece of software called the terminal. On Mac, just go up to Spotlight and search for terminal. It's called terminal.app. You'll find it in your applications utilities folder. On Linux, basically just find xterm or GNOME terminal or something like that. They pretty much all do the same, and they give you a little prompt like this. This is actually what we're going to be learning about to do, but here I'm starting off on my laptop here, which is a Mac. And basically the command's the same. To be able to SSH to a machine, you need to know the host name of that machine, And you can see here on the login part of our website, we had the name of those machines, but I'm going to show it to you here. So basically, you just type SSH, and you type the name of the machine you want to connect to, which in our case is flux-login.engine.umich.edu, minus L, the username you want to connect. Now on my Mac here, my username is the same as the cluster username, but I'm going to go ahead and specify my username. And that's it. So the first thing it's going to ask me is for my M token. Now, if the machine you're connecting to doesn't use two-factor authentication, it's not going to ask you for this. But I'm going to go ahead and type in my token code. And if the token code is accepted successfully, it'll prompt me for my password, which is the same password I used to connect to Wolverine Access. And you can see here, my prompt's now changed, but it's effectively the same. But you'll notice I'm now brockp at fluxlogin1. So this actually allowed me to SSH to the compute node. So again, SSH, the name of the machine you want to connect to, minus lowercase l, your username. And that will let you connect. You can SSH to machines multiple times, so you may find it easier to have multiple terminals open, such that you can be editing a file in one, monitoring a job in one, and doing kind of administrative commands in another. You can connect as many times as you need. That said, specific to Flux, M tokens are only good once. So here's the thing. If you typo your password, you have to wait for a new token code to be generated. If you enter your token code incorrectly, it'll just say, I'll prompt you for enter your mtoken passcode again. That means you typoed your mtoken code, so you're still good. But if it ever asks you for your password, you've used your token code. So basically, Terminal, Mac, Linux, they all work the same. So it's built in. You don't have to install any special software. Now, Windows, on the other hand, is slightly different. Windows, you are going to have to install some software. And in this case, I'm using the virtual sites machine. This is virtualsites.umich.edu. So you can see here, I've already logged into one of the standard machines, and the Windows machines on campus already have SSH installed, but at home, you'll need to install your own. So on a Windows machine on campus, you go to Internet and Email, and you'll see a couple different tools here, but the most common one is PuTTY, and you want to run PuTTY. So you can download PuTTY, just go to Google, search for PuTTY. It's a free SSH client that is well understood, so it's known to be secure for Windows. And so the interface here is a little bit different. In this case, we go ahead and enter the hosting we want to connect to. So remember, that's flux-login.engine.umich.edu. SSH is the default, port 22. That's all the same. So you go ahead and click open. The first time you connect, it's going to ask you whether or not you want to trust this key. I forgot about that because I had already connected to Flux before. The key thing is already accepted, but even on the Linux and Mac version, the first time you connect to a machine, it's going to ask you, like, do you trust this key? Generally, you can just assume yes, but if that ever changes, you need to be a little bit wary about what you're connecting to. Maybe contact us at hpc-support to make sure that the machine is actually the one you intend to connect to. PuTTY, after you hit connect, will prompt you for your login name. So this is, your unique name. And again, it asks you for your M token. So I'm going to type in my new M token code. If I've typed it in correctly, it'll ask me for my password. Okay, it looks like I did. So type in my password, and as you can see, I get the same result as I did with the Linux and Mac version. That is, you see down here that I'm now on flux-login2, which is one of the login nodes for Flux, and I'm at a normal Linux prompt. So SSH is how we connect, and the host we connect to is flux-login.engine.umich.edu. Your username is your normal Umich username, and your password is your normal Umich password. One extra note to make here. Your account on Flux is not created by default. It's not like your normal computing account. You have to go to our website and fill out an account form. It's free, but if you're trying to connect to Flux and you can't connect, that's generally wise because you don't have an account with us yet. If you think you already have one, send us an email, hpc-support, and we'll figure out kind of where your account is, and Dan will help you out. Okay, so this is how I connect to the cluster so I can run commands on it. Any command I type in this window now is not being ran on my Windows machine or my laptop. It's being ran on the cluster login node, which has many people on it. So the other thing is, how do I transfer files? So on Windows, there's a number of different tools, but the one I'm going to show you here, which is again under the Internet and email, is WinSCP. And WinSCP is also a free Windows tool. WinSCP implements SFTP and secure copy. So we are able to transfer files back and forth to the cluster from our Windows machine. So this is a Windows example. The host name to connect to, you can use flux-login, but I don't recommend using it. It asks you for your mToken code, and for large file transfers, you'll get cut off. We have a dedicated machine that doesn't allow you to SSH into it, but allows you to transfer files, and that machine is flux-exfer, short for transfer. Oop. Tom, I'll go back to the Mac version here in a bit because I'm going to demonstrate a different tool. But so WinSCP works. So the machine I connect to is flux-exfer, short for transfer, which has a 10 times bigger connection to the internet and doesn't have any limitations on the size of files you can transfer. Username is the same. Password is your password. You'll notice here it prompts me for the key again, and I'm going to say yes, accept the key. You'll notice here it never prompted me for my mToken. The reason is transfer host does not ask for your mToken. If you try to transfer files with Flux login, it'll work, but it'll ask you for your mToken, and sometimes transfer programs choke on that. So I highly recommend using flux-exfer. It doesn't prompt you for your mToken. So if you're using a tool like Text Wrangler or something like that that lets you edit files on a remote system over SSH, have it use flux-exfer. It works, and it doesn't do any of your mToken craziness, so it all works there. So when I actually connect here with WinSCP, what I see here on the left-hand side, I see my location on my Windows machine. On the right-hand side, I see my location on the cluster. So this is pretty much the same for all Linux and Unix machines. So I pretty much just select the files I want and I drag them left to right. If I want to move a file from the cluster to my desktop, I just drag it from the right side to the left side. If I want to move upload from my machine to the cluster, I drag from the left side to the right side. And so that's pretty much the basics there. So that's how you transfer files on Windows. Again, Windows doesn't have any of this built in, so you need to download. And again, the tool we're using is WinSCP. Okay, so now I'm going to show doing it on Mac, and from there I'm going to actually do everything from Mac going forward. Because everything we do is going to be the same on all the machines. Whoops. What is the difference between flux-exfer and flux-login? Okay, so flux-exfer has a 10 times larger connection and does not allow you to log in to run commands. You can't log in and compile code on flux-exfer. It only accepts the commands SCP, SFTP, and rsync. So it's only for transferring data. Regular users cannot log in and create a normal shell on it. If you try to SSH to it normally, you'll get our banner, but you'll never be able to type a command. Flux login is the one that actually lets you log in and run commands. Flux login has just a normal Ethernet connection to the outside world. People can log in and run commands, so sometimes they crash because people will run a test on it and they'll have a memory leak and it'll run a machine a memory. And so it's really not necessarily the most stable um, platform for doing transfer of a large amount of files that may take a long period of time. So a login node is where you do all your interactive work. That's where we're going to be spending most of our time. That's where we're going to SSH to run commands, to manipulate files, to submit jobs, things like that. The transfer node is dedicated just for transferring data. That's the difference between the two. Yes, you can transfer data with a login node, and with a normal Linux or Mac machine, there is no restrictions, and you can transfer stuff back and forth, and you can log in and create shells. The fact that we've split that functionality is specific to our cluster to try to make a more stable, performant environment for users transferring large data. Did that answer your question, Ali? Okay. Okay. So I'm back on my Mac here. And so I have my terminal here. I'm back only behind my Mac. And there's a couple different tools I can use. There's GUI applications. You can get things like CyberDuck or FileZilla. Those also both work on Windows to give you a nice GUI for transferring files back and forth. Pretty much, they take the exact same options. You use SFTP. The host you want to use is flux-exfer. .engine.umich.edu, and the username and password is the same. But I'm going to demonstrate using the SCP command, which can actually be really handy. SCP is a command line tool that stands for secure copy, and the format is what source destination. So if I want to copy a file from my local machine, I'm going to make a file called A. If I want to send A from this current directory to the cluster, I would say scp A, the file I want to send, or scp -r directory if I had a directory called directory I wanted to send, if I wanted to send a whole folder full of stuff. Right now I'm only sending a single file, and I would say brocp at flux-exfer.engine.umich.edu colon where I want it to end up. So in this case, I want it to end up in my home directory. So what I'm doing here is I'm saying secure copy the file A as brocp at the host flux-exfer. So again, we're using the flux transfer host colon where I want it to end up. And so if I do this, it prompts me for my password. Notice no M token. And it transferred this empty file to the cluster. If I want to go the opposite direction, I could do scp brocp at flux-exfer.engine.umich.edu home brocp A, and then directory I want to send it to. So in this case, my Mac, I want to send it to users brocp, which is the equivalent of my home directory here. And that took the file from the cluster, the file A from the cluster, to the folder users brocp, and that file is now there. So that's the scp command. It's really handy if you're on a Linux system or a Unix system and all you have is command line access. SCP is the most common way how I transfer files. If the username on your systems are the same, you can actually shorten this a little bit. You can just do scp flux-exfer.engine.umich.edu. And why can I do this? It's because I can do this because the username on my Mac is the same as on flux-exfer, so it's going to imply brocp. So I only need to specify the username if my username on the two systems that I'm connecting to are different. So what's handy about this is I could SSH to, say, login.engine.umich.edu, which gives me a prompt like this. And then I would want to transfer a file, say maybe from my IFS space on login.engine to the cluster. I could actually do that using the scp command. If you want GUIs, again, CyberDuck is probably my favorite for Mac, or FileZilla is another good alternative, and both of those also work on Windows. So that's basically the basics of transferring files. Now I am going to demonstrate one other tool for transferring files, which is a non-standard one, but it's one that we support on Flux. We support something called Globus, and Globus is So we have a link here under resources, login nodes, Globus, and we have a tutorial video here. Globus is neat in that you install a little tool on your laptop or your desktop machine, and you give that machine a name, and then you can transfer files to and from that machine as long as that tool is running through a web page at globusonline.org. And you can transfer files back and forth. The nice thing about Globus is, especially over long distances, it's faster. It's more reliable. It deals with machines rebooting, them moving around the internet, network connections coming and going away. So SCP, SFTP, if a machine kind of goes away for a little while, the transfer will stop and you'll have to start over. With Globus, you don't have that problem. You can set up the transfer in the web page, and so I'm going to go to Globus Online and actually show this. I've already set up endpoints and create a Globus account, but you can go ahead and do this yourself. But this is the Globus interface. It's all done in a web page, so there's no tool to install on the machine where you're controlling transfers from. Only tools to install on machines where you want to transfer, and they're very easy, and you don't have to set up any firewall rules. But the names are, for example, if I want to transfer, connect to Flux, is umish pound flux. It is asking me for my username and password. And remember, we allow Globus from off campus. And so what this is going to do is it's going to show me the Flux computer. This is my home directory on Flux on the left-hand side. And if I want to use my personal laptop on this side, where I already have the software running, this machine is called MacFoo. And this is now going to show me my home directory on my laptop here. And to transfer files, I just select a directory, click this, and it queues it up. It's an automatic thing. So if I want to start a transfer from the cluster, let me find something that's relatively small. If I wanted to transfer this file to my Mac, I would select it and I would click this arrow and it would create a transfer. This is batch, so at this point I can log out and go home. These two machines, Flux and my laptop, are directly talking to each other. This machine over here could be a different one. This could be one of the NSF Exceed machines, like Blacklight, and it'll ask you to log into the Exceed portal to get a token. And now when you transfer files between them, you don't have to include your laptop. Our transfer node with a 10,000 megabit connection and Blacklight's server with a 10,000 megabit connection are now talking directly to each other. So you don't have to transfer files to your home network or anything like that. So that's pretty much it. Oh, and it emails you when the transfer is done. So I recommend that you check out Globus as an alternative to doing using SCP and SFTP. Again, it's not a standard thing, but it is something you can install, and it's all free software, and it's run by the University of Chicago. Okay, so that's how we connect to and from the cluster. Okay, so now that we are connected to the cluster, I'm going back to my terminal here on the login node where I've already SSH'd in. We're going to talk about basic Linux commands. So these commands apply to any Unix clone. So this works on terminal on the Mac, and this works on any Linux machine you're on. So the very first thing is to try to understand what the file system looks like. So the file system consists of folders or directories, and then of course files. How is the Unix file system organized? Well, it's organized in a hierarchy. That is, folders inside of folders. And so let me go ahead and show you something. Just a quick sketch. So you should be seeing as a blank white page right now. So the directory on Unix always starts from something called slash. Let me make something a little bit smaller. And so we start with slash, and basically it's a hierarchy. So then we go to slash dir1, or we can go to a different directory name. dir2. And these can point to their own folders or files, etc. So the start of the file system or the root of the file system is always slash. So we end up referring to something as slash dir1 slash, other folder slash file. And so it's important for a lot of these commands when we get into it is if we start with a slash at the front when referring to the file, this is special in that this is what's called an absolute path. That means I'm starting at the root of this tree and I need to specify everything in between. If I am already in this folder, that is slash dir1 slash folder, for a lot of these commands I can refer to just file without any prefixing slash, and that is called a relative path. That is, I'm referring to things that are in the folder I'm currently running the command from. And that's handy because now you don't have to type these big, long, absolute things. But sometimes it's handy to do absolute. Sometimes it's handy to do relative. If I was inside just dir1, I could refer to folder slash file. So again, no leading slash, but because I'm inside this directory already, I can go directly to folder slash file. So it's going to depend where I'm located. So does that make sense? Is there any questions about that? Any question? Okay, so you'll actually see how this works now. So the very first thing we want to know is, where are we? So when we first connect you to the cluster, you get dumped into something called your home directory. And you can, and this is the same on all Linux machines, it's something that's set by the administrator when they create your account. Your home directory is kind of like your My Documents or Documents and Settings folder on Windows, or users/username on Mac. It's your space. This is where you kind of get to, write files and do stuff. You have write permissions here. This is where you can upload data. You can put your own source code. You can install software without talking to the administrator. How you find out what folder you're in, there's a command called pwd, which I ran here. That stands for print working directory. So what directory am I in? And it printed out /home/brocp. So you can see that I'm in not the root, I'm inside the folder brocp, which is inside the folder home. So that's how I find out what directory I'm in. I can navigate between folders using another command, and I can create folders and things like that in places I have write permissions. How do I list what's in the folder I'm currently in? That command is ls. ls is short for list, and if I run this, it lists all the folders in my directory. Now, if your terminal supports color, which mine does, and a lot do by default, in my case, anything that's blue is a folder, anything that's not is a file, and sometimes different colors have certain special meaning, but generally blue folder, file without. So this gives me a list of files. As you can see, I have a lot of things in my home directory, so sometimes it's handy to get only a limitation of it, and I'll cover that in a minute. But how can I navigate to one of these folders? Well, if I wanted to navigate to this WRF folder, Weather Research Framework, I could use the command cd, which is change directory. So there's two different ways I could cd to there. I could say /home brocp wrf, because that is the absolute path to where that folder is. It's a folder inside the directory brocp. And so if I type pwd, there I am. Now, though on the other hand, because I'm already, if I go back to just the folder home brocp, I could just type cd wrf. See, because I was already in this folder, if I say CD without any leading slash here, it's relative. So it's relative to the directory I'm already in. So I can switch directly to that directory. So you don't have to type these big, long, absolute paths. Sometimes it's handy to be explicit, but you can also just do things relative. Okay, so there's a couple of additional handy options to ls. So I'm going to actually use this WRF directory to do an example. So I type ls, there's nothing in here. Okay, looks like we have a question. How can we go to one folder or the other one without using cd? Actually, cd is the only command that lets you switch between folders. It is the change directory command. It is the command that you do it with. For file transfers, those GUIs we were using, they do it all for you. But cd is actually really the only way to do it. Okay, so if I go, actually, let me go back to my home directory here. So I got a bunch of files here. What if I wanted to have a little bit more information on these files? What if I wanted to have the file sizes and how old they are and who owns them and stuff like that? Well, a very common option to ls. Options to Unix commands are generally -option. And you can do minus option, minus option, minus option, or you can say minus options all put together. So the first one I'm going to show you here is -l, which is long. And you can see here now when I run this, I get the same listing of files on the right-hand side, but I have extra information. For example, that WRF folder is from August 15th, 2009. It is this big. This is bytes, so it's 4 bytes. And it's owned by me, and I have these permissions on it. We're not going to cover permissions because generally users don't run into that problem. But this is a very useful command for finding out how big something is. I'm going to show you a little trick though. ls -l -h. -h is human readable. And so all these files and directories are using the same units, which is handy for sorting. But sometimes I just want to be able to read stuff. If I use -h, you'll see here that that WRF directory is now marked as 4K. And that this WRF tarball is marked as 28 megabytes. So -h is handy for human readable. You'll notice when I did that, I did -l, -h. You can't just say -lh. You can put those options together. Order doesn't matter. They're all just options to ls. So another handy thing is sometimes you want to know the files in date order. You can say -t. So -t sorts them by time order. And you can see here when I ran it, I got a different set of files. I'm going to add -l so you can see here what it did by default is the last file shown is the oldest one. If I want to do that in reverse, I can say add an R for reverse. And now I have the newest file, which is that empty A that I uploaded in the example for uploading data. So ls -l to get extended information, -h for human readable, T to sort by time, R to sort in reverse. There's a lot of options to ls, and a handy command for figuring out all the options for something is you can Google for it, or you can type man, which is short for manual, and then the command you want more information about. So man ls, if I hit enter, here is the manual page for ls, which has a ton of options for different bits of information. So here's your -h or -- human readable with -l print sizes in human readable format. Example 1K 234 megs 2 gig. Okay. So ls lists files and directories. CD changes between them. PWD shows us where we are. I'm going to show you a little trick. You say I was in this WRF folder, and I wanted to run a command that was in here, but I wanted to refer to a file in my home directory. I could just do home broc p a, the absolute path to refer to it, But that could be really deep. Well, what I could do is there's a special command that's dot dot. Um, dot dot means the directory above me. So if I do cd dot dot, okay, I'm in Word. If I do cd dot dot, it puts me into home broc p. If I do cd dot dot again, it puts me into home. See? There's also another special one that comes handy sometimes. This is a single dot, and that really just means the current directory. So if you want to be explicit about something, you can say dot slash, and that means where I am slash something. So dot dot and dot are special to mean dot dot means the one above me, dot means the one I'm currently in, which can be handy little shortcuts, but most of the time you don't use them. I tend to use dot dot way more often than I use dot. So this is actually kind of weird. I could do this: home broc p dot dot broc p dot dot broc p. Where should I end up at the end of this? I'm saying go to home broc p, up to home, back down to broc p, up to home, back down to broc p. So this is a convoluted example, but as you can see, in the end, I end up in just home broc p. Because I'm going forward and backwards. So it's kind of silly, but it's handy if you want to refer to, say, common data that you stored in a directory that's just in one directory up. So see, for example, I could cd, I'm in my home directory. You do cd dot dot slash, if I wanted to try to switch to Dan's directory, if I had permission, I could say dot dot slash Dan Barker. This is a relative command. You may not realize it, but it means one directory up from where I am into the directory Dan Barker, and it's permission denied because I can't see inside Dan's directory. But let's use an example of if I go to the WRF directory, if I wanted to cd dot dot this directory, that works because that means go up one from where I am, which is WRF, and then down into that directory. Okay. Now, there's a couple shortcuts. You'll notice there, I just typed cd with no options. That always takes you back to your home directory. That's a shortcut. cd by itself always takes you back to where you were. Also, let me show you something kind of cool, and you will use this. Get in the habit of using this command. It will, and it's not really a command, it's a shortcut. You will use it hundreds of times a day. I know I use it hundreds of times a day. The tab key. It's kind of hard to show because it's not a command you run. But say I wanted to cd to my no backup directory, which is in slash no backup. If I type no and then press the tab key, it completes it for me. See? cd, and this works in all cases where I'm referring to file paths. If I press tab, it completes it for me. Now, if I type br and press tab, it yells at me and it dings. And if I press tab again quickly, it prints out all valid options that start with the letters br inside this directory. So you can see here bro. I can press tab again. There's two options with bro. If I say ck, that is unique. It completes it for me. I'm done. And so tab completion works great, and it works with dot dot too. Broc p dot dot slash Dan slash tab gives me that. Dot dot Brit tab gives me that. Where do I end up? I end up with permission denied because I don't have permission to master directory. But where I was ultimately going to end up there was no backup ms Brit. So tab is super, super handy. It also works with commands. So if I type just C, press tab twice, if it's a really long list, it'll say, do you really want to do this? But let's say I want to do pwd. If I type pw and press tab twice, these are the valid commands and directories in where I currently am that I could run. One is pwd. One is pwdx, etc. So tab is your friend. Just start typing, and if you can't remember the name of the directory, but you can remember the first couple letters, or if you did upper or lowercase, do what you remember, press tab, and it will speed it up. Most of the time, even if I have long directory names, I only type the first 2 or 3 letters, and I press tab. always. That's just my workflow. I do it without even thinking about it. Okay, so CD, I'm back to my home directory. Okay, so that's how we navigate around. That's a shortcut. So PWD shows where we are. LS lists files. CD switches directories. What if I wanted to create a new directory? Most of those file transfer tools we had lets you, say new directory, new folder. But the command is really just make dir. MKDIR stands for make directory. So if I want to make a directory called directory1, I type that. Now I can CD to directory1. What if I wanted it to be absolute? I can do that also. You'll start to see a pattern here. They all take the same kind of options. If I want to make a directory2 in home brocp directory2, I can do that even though I'm not inside my home directory. Because I can just refer to absolute path, or I could do something similar. I can do that. So notice I basically used everything we have used thus far here. I made a directory called directory1. I used CD with a relative path to move inside of it. I used PWD to show where I am. I used makedir with an absolute path to make a directory outside the folder I'm currently in, because remember I'm inside directory1, but I made a folder called directory2 inside my home directory. I CD'd using a relative path, using ... as a shortcut to back up to my home directory and into directory2. Use PWD again to show that that was the case. And then I did another make directory. Instead of using the absolute path like here with directory2, I used ... directory3, and it created the folder directory3. So that's using everything. So there's multiple ways to do it. You can use absolute or relative, and you can use the shortcuts and things like that. Most of the time, you're going to be using relative. Once you get used to it, it's much simpler and conciser because you don't have the big, long leading path in front always. Okay, so one of the most common things people need to do is edit a text file. There's multiple editors. The one I use most of the time on the cluster is called VI or VIM, which stands for VI Improved. Its learning curve is pretty steep, but it's very powerful once you get used to it. So I would look up a Vim tutorial if you want to learn it. Another common one is Emacs. Those generally are both of those are generally installed on systems. I'm going to show you a really simple editor. You can use a text editor on your own machine and upload files back and forth, but a lot of times it's easier to just edit directly on the cluster. And the command I'm going to use for that is pico or nano. They're actually identical. Actually, it's nano on our system, but pico and nano take the same options. So if I want to edit a file, I say nano, the file I want to edit, give it a name. If you want to do the whole .text thing, it doesn't care about the .text. But unlike Windows, we don't care about the suffix. So we can edit it. And this is Nano. It's a completely text-based text editor. The mouse does nothing in here. But I can just start putting data in here. Any type of thing I would want. This could be a source file, a .c file, a Fortran file. It could be a data file that's in text, whatever. At the bottom here, you'll see these are basically the options. The caret means to control. And so to save, you actually say write out. So what you'd say is hold the control key and press O. It'll say a file name to write file to. Because I opened Nano with a file name, it's already filled into file name, but I could rename it. Like say I wanted to save an edited version. But in this case, I'm just going to stick with the file name. Hit enter, wrote 6 lines. So that saved the file. See down here, exit, control X. I'm going to say control X. That exits. I type ls. There's my text file. So Nano, basic text editor. If I want to open it back up, I just say Nano, that file name. And here's my data. Okay. Any questions about that? So Nano is a very simple text editor. It's a clone of a piece of software called Pico, and they take the same options. So if you're on a system and it has Pico instead of Nano, that's fine. It behaves the same way. You just type Pico, instead of nano. And again, the very powerful text editors are things like VI or VIM and Emacs. They have a much steeper learning curve. So in terms of basics getting around, you can do this. So this makes a basic text file, so you can use this for making source code or things like that. Okay, so exit. Now, next basic command is actually, it seems kind of silly, but it will make sense later. What if I just want to see the contents of that file? If I wanted to just have the contents of that file, oh, okay, so there's a question about nano. Okay, so the question is, how can one modify the content of and save the modification in nano? So basically, I have this file, file1.txt, and I want to edit it in nano. I just say nano file1.txt. Here's what I already had in it. I could add, I'm just adding text. And then to save it, again, is just like before. Write out. Control O. File name to write. I'm going to leave it to file1.txt. Hit enter. Wrote 9 lines. That saved it. Control X to exit. So it's just like when you created a file with nano, you do the same thing to edit it. You just say nano, file name, type what you need, Control O, enter to save, Control X to exit. Okay, did that answer your question, or were you trying to get at something else? Okay. Okay, so if I wanted to just display the contents of that file, I could use the cat command, and it's going to seem a little silly, but it'll make sense here in a minute. If I type cat file.txt, it just prints it to the screen and gives me right back to the prompt. It's handy if you want to see the contents of a file and be able to go directly next to the command. It's also handy if you kind of want to combine 2 text files together. So cat literally just prints it to the screen, does nothing else. But it's actually short for concatenate, because here's what you would do. If I created another file called file2.txt that has, this is my new great data set, and say these were 2 different time series data, and you wanted to combine them together, I could use cat file2 and use the concatenate operator or the redirect operator to send the result into another file. So check this out. If I type cat file2, I get what I expect. It prints it to the screen. If I do this, it prints nothing. But what I've now done is it's now inside file3. So that is actually just sending the result there. So why would you do this? This is not actually how you want to copy files. I'm going to show you how to copy files next, because I forgot to show you how to copy files. What you would actually want to do here is, if you were running a command, if you were running, say, MATLAB, and you wanted to capture what it printed to the screen to a file, you could run MATLAB -r, my m file caret What this would do is, instead of MATLAB printing to the screen, everything that MATLAB prints to the screen would end up in that MATLAB.txt. Now, there's an extra special thing here, because check this out. If I run catfile.txt, again, you would expect me to have 2 lines in that file. It doesn't actually work that way. If I use a single caret, it overwrites the file and replaces the data. If I do caret with no space in there, now it does what you expect, which is to append to the end. So if I have my dataset 1 and my dataset 2, if I do cat file 2, file 1, what this did is it added the contents of file 2 to the end of file 1. That's why I would want to do that. So I'm actually going to do something funky here. So I'm going to so what I've done here is I've created a simple MATLAB file. If I ran MATLAB by itself and I wanted to run that text, I would have to do something like it would prompt me to type in commands. Now, if I have a piece of software that wants to type in a command, I would have to, type it in. Well, what if I don't want to do that? What if I want to automate this? Well, what I can do is I can use the caret operator in the other direction. And what this does is it feeds text from that file in line at a time. So if you have a code that you want to automate to use like a batch system, but you don't think you can automate it because it prompts you for input, if you know what that input is, what you do is you put the input that you would need to text on every line of a text file, and then you would run that command and you would say less than that text file, and what it will do is every time the command MATLAB prompts you for input, it takes the next line from text.m and feeds it in automatically. Super handy. Okay, so I used cat to kind of copy a file. That's not a good thing. There's actually just a copy command. So if I want to copy file 1 to file m, I can just type cp source destination. I can combine that with directory. So if I wanted to move this to directory 2 or copy it to directory 2, this works. So what I did here, I said up one folder, down one folder into directory 2 / why did I not give a name? What it'll do if I don't give a name, if I ls directory 2 now, it's still called file1.txt. If I don't specify a name in the destination folder, it just uses the name of the source file. What if I wanted to copy an entire folder? You'd say copy -r, the directory you want to copy, and I want to copy it, say, here, and I want to copy it here. If I type ls, there's my directory. If I cd into that, there's file.txt. So that's copy. If I want to rename or move a file, it does mv. So file m to file x. No more file m, it's now file x. And so I can, do just individual files and it stays inside the directory, or I can prefix with ... and / and things like that to refer to other directories. So copy and move. Copy -r for recursive, etc. Again, look in the man page for all of these things. Lastly, what if I have a lot of data? So what I'm going to do here is okay. So what I did here is if I open up file1.txt, I had everything, but I appended the numbers 1 through 100 in it. So this is really long. This is really long. So what if I wanted to see just the last couple of file lines? Tail -n 10 shows me the last 10 lines of the file. But if I want to see the first couple, head -n shows me the first 10 lines of the file. See? That is actually quite handy, because if you go through the advanced command line stuff, well, we show you the pipe, which is where you can combine these together. So what if I wanted to see the middle 10 lines? Well, what I would do is I would say, okay, show me the bottom so many, and then show me the top of that set, so you can kind of restrict it. The format of the file. Can you do cat f1.text redirect to f1.m? Yeah, that works because nothing in Linux actually cares about the contents of the file or the suffix of the file name. You can totally do that. So if your text file is actually MATLAB M code, you can totally just rename it to an M file. And so you can use move to just rename it. You can use copy to make a copy of it with a new name, or you can use cat to redirect it. Most of the time, you just want to use, copy and move. You actually rarely want to use cat. And so that's everything I had. So you guys have questions for me? Something you want to see? Again, send questions to hpc-support@umich.edu. This is being recorded and will be posted on our YouTube channel there, so you can refer to it later. Oh, question is, can I explain tail one more time? Yeah, tail shows the last so many lines of a text file. So tail, if I do tail, so tail will print the last 10 lines of a file. Mine is n 20, prints 20. So the default is print 10, but you can say, show me the last however many. Tail shows the end of the file, the tail end of it. Head shows the start of it, the head end of it. How do you create permanent shortcuts located to programs located in system folders? You're talking about how can you refer to a binary you have that's not a normal system one to run. You want to be able to type that command anywhere. So like, for example, if I go to my bin directory, I have this command called dstat that just prints out the statistics of the system I'm currently running on. I want to be able to run that in any directory. So that's actually handled by something called path. Path is an environment variable, which is a colon-separated list of directories I want to look into for commands. So if I type a command by itself, the system's going to first look in the folder user cane MATLAB bin. That's how I found the MATLAB command. And if it's not there, it's going to look in this folder. If it's not there, it's going to look in this folder, etc. There's also a command called alias. So I could make alias called dstat that's equal to home rugby bin dstat. So an alias is just, you could shortcut. So if you commonly did something, so a lot of times people make an alias called ll. So right now if I run ll, oh no, whoops, sorry. If I run ll, it prints nothing, but it's a very common shortcut people make for ls-l. What they would do is they would run alias ll equals ls-l. So you can use alias, but realistically, if you have a folder full of commands you want